Hello, AP Stats. It's Coach Jay, aka, as everyone's been calling me, Bob the Builder. Hope you're having a fantastic day today. We are going right after section 8.1a, and I hope you're ready to work a little bit, get 10 minutes in, and get it going. This is a good introduction for Chapter 8. Kind of already done that introduction, but I do want to just quickly go over just a brief podcast over what Chapter 8 is over. So with that being said, let's get started and let's go over the notes just real quick, okay? All right. Hey, as we begin, I will tell you real quick, the first 5 individuals who come to me and say, "Go Blue," at the beginning of the block day class will get a ticket. First 5 people who tell me, "Go Blue," don't yell it out to me. Just kind of come to me and say, "Hey, Coach, go Blue." And I will give you a ticket there that just tells me that you watch the podcast. Don't tell other people. Honor system. Let them watch the podcast. Encourage them to watch the podcast. But I will do that for you. Okay? All right. I told you I'd keep it under 10 minutes. So let's go. Hey, as we go into this section, we talked about in Chapter 8 how we're going to construct confidence intervals. Okay, so we'll start off with that. I'll get my notes rolled up here. We have what's called confidence intervals. All right, that's what we talked about. As far as Chapter 9 is concerned, we're going to go to more significance tests. You'll see that as well. And in Chapters 10 through 12, we do both confidence intervals and significance tests. Okay. All right, so that's just kind of telling you where we're headed. Now, what I'm going to do is I'm just going to take this as a sample here, and we're going to have a quick activity. This activity is not one that you will need to do, but you'll kind of get the idea of the basics on how we find or how we construct a confidence interval, okay? First of all, as we looked at this, it says the midterm exam scores follow an approximately normal distribution. Note, because that's the case, if we were finding the mean, we would then be able to say that sampling distributions are also approximately normal. That's something that a lot of people missed on the test. You would not have to use the n is greater than or equal to 30. You wouldn't have to use that because it was already stated within the problem. Again, when we're talking about sample means. Now, it is with an unknown mean and a standard deviation of 10. So the mean we do not know. So the mu of this we're not sure of, but we know the standard deviation to be 10. Notice the notation because I'm talking about my population. It says estimate the mean midterm exam score by taking a sample of 4 students. Okay, so what is my population? Population in this instance is talking about the current AP stats students. Okay, and specifically with their midterm grades, right? So current AP Stat students and their midterm grades, if you wanted to add that there, okay? The parameter, because it's talked about my population, will be mu, and this is the mean of the whole population, okay? You know that. Now, when we talk about a statistic, this is X bar. This is the mean of the sample, okay? And we can find that because the sample is taken of a sample of 4 students. So the sample would be 4 students. And someone asked me earlier, which I thought was really good. The 4 is the sample size. 4 students is my sample there. So just a heads up there. So in conclusion, we could say we're going to take a sample. So we could simulate this, okay? We could take a sample of, let's say, X bar, okay, of that 4. And we could say based on the sample, we estimate the mean exam score as, and we're going to just throw out a number. We're going to say 80. Okay, we'll say that was the average of my 4. I'm throwing this out here. This could be anything depending upon your specific value that you found, okay? So based on the sample, we estimate the mean exam score to be 80, okay? So we've got X bar that's there. Now, this value that we use to estimate this parameter, we call a point estimator, okay? Point estimator, all right? Again, it is not fact that the mean score of my population is 80. But what we're going to do is we estimate this parameter, and we call that our point estimator, okay? Now, what is a point estimator? Remember, it is a statistic, right? Because it's taken from my sample. So it's a statistic that provides an estimate of a population parameter, okay? It's pretty much restating what I just said at the beginning, but knowing that this is taken from my sample, so the value of this, the 80, is a statistic, okay? Because it's drawn from my sample. Don't forget, though, 80 is a statistic. The sample is the 4 students. See the difference there? Hope you see the difference. All right, next part. It says this. The value of that statistic from a sample, we call a point estimate. Okay? So again, the value of that statistic from a sample, we call that a point estimate. Again, pretty much the same thing, all saying the same thing, okay? Ideally, a point estimate, again, is our best guess. We don't know this for fact, but we could say that the 80 is a best guess of the value of an unknown parameter, okay? All right, so let's continue. Literally, I'm on the clock right now. I've got 3 more minutes left, okay? So this will be our last slide. As we look at this, how would the sample mean vary if we took many SRS of size 4 from the population? Well, if we did that, this would then go into a sampling distribution, okay? It's a sample of a sample, right? Samples that we would take of size 4. In this instance, we could say, what is the shape of this? Well, it would be normal. Why? Because as we look back here, we found that this was approximately normal, as stating previously, because it's normal because population is normal, right? Very good, okay? Now, what about the center? That's a little bit weird. We know that this would be the center is mu, right? Because we know that mu of X bar would be equal to mu. But the problem is we don't know mu. That's what we're trying to find. So this is the unknown mean. We don't know what it is. It's the unknown mean. Now, the spread would be more of our standard deviation, right? So this would be the standard deviation of X bar, which, oh, by the way, it would have to follow our 10% condition to be able to use this, right? And remember, the formula is the standard deviation of the population over the square root of n. So this would be 10 over the square root of 4, okay? Now, does the 10% condition, is it satisfied? That's the question here. The answer is yes, because as I look at it, little n is less than or equal to 1/10 of my population n. Because we know that my little n is 4, and is that 1/10, is that less than or equal to 1/10 of my population? Absolutely. Because n, we're going to assume that n is going to be greater than, if I multiplied by 10, that 40 would be less than or equal to n, right? So if I did that, 40 is less than or equal to big N. We're going to say yes in this instance, though I understand that for AP Stats at GAC, that could be a little bit different. But we're going to just say that the condition is met because the population is greater than or equal to 40. So then we can go to this formula like we were doing up here. Right on this side, we can say that now 10 is divided by 2, which would then be 5. So my standard deviation of X bar would now be equal to 5, okay? And now let's wrap it up here, and we'll continue this going forward. That means 95% of the X bar values will be within what of the population mean? Mu. This is a little bit interesting, okay? 95% of the X bar values will be within blank of the population mean. Well, we remember that right here, this would be our mu, correct? And we know that this would be the line that follows, right? And this is the sampling distribution of X bar. We also know that big N, because we showed that it was normal, right, is mu of X bar comma standard deviation of X bar. We know that, correct? So as we look at this, and by the way, 5 is here, right? So as I look at this, here and here, we have the rule of 68 and 95%, right? So 95% of the X bar values will be within blank of the population. Well, if we go right and left, this is going to go 5 to the first standard deviation, right? And based on the empirical rule, to get to 95, we have to add 5 more. So we're going to go 10 to the right and negative 10 or 10 to the left. So it's going to be within 10 of the population mean. This value, 10, is called our margin of error, okay? I'm going to stop right there. That is exactly 10 minutes. Hey, check this out. We'll continue with this tomorrow. Have a fantastic day. Bye.